Hi, and welcome to a new series that I'm going to be starting. I think it's time I shared what I did for OBS to be able to do what I do. So this is going to be accurate to January 2024, and this is going to be handling sort of up to 4K, but not including HDR recording, because it's not something I've got a lot of experience in, so it's not something that I want to go into at this point. First thing you need to do, and these links will be in the description, is go ahead to the Open Broadcaster software, download the latest release. At the point of this video being done, it's 30.0.2, and I don't really see any problems with this going forward. This should work on newer versions. Next thing you need to do is download some plugins for OBS called the REA Plugins VST-FX Suite. You will want the 64-bit version. This is so we can do things with the microphone to make it sound a little bit more better. Another thing you want to do is download Audacity and install that. You're going to be using that to be able to listen to your audio and make sure you're following the steps and you're hearing the changes that you need to. The last one that you need is going to be this picture. This is basically for color calibration. So we may as well just get started with this bit, because this is you're looking at this and going, huh? So one of the things that I deem as important in regards to recording is actually getting the best quality that I can both get visually and audio-wise in the recording. One of the ways that I do this is to ensure that I'm actually outputting colors in a standard format. If you are a NVIDIA user and on Windows 11, go Show More Options and load up your NVIDIA control panel. What you want to do is head over to the Adjust Desktop Color and Settings. In here, any displays that you have attached will be displayed, and tick the Override to Reference mode on both of them, or as many monitors you got, and click Apply. This means that the graphics card will be outputting the image in a standard format in regards to color balance, and this is key to getting your color information correct in your recording. The next thing you want to do on a PC is go and find your change resolution and go to each display device, and in here we've got color output format. You may find that it's on Use Default Color Settings, override it, 32-bit, 8-bit, and then change this to RGB and tell it to go to full. The reason that I'm saying this is if we look at this picture, and you can see where my mouse is, full color range goes from here all the way to here, because it uses a 0 to a 255 in reference to the color. If you use limited, it starts at 16 and goes up to 235. So you end up missing out on your super white and your super blacks. On PC, there is no reason why you shouldn't be outputting in full mode, so you get all the color representation on the screen that you possibly can. Your next trick that you're going to want to do is, whilst you have this up, is follow these instructions. It's one thing to have the graphics card outputting the colors in the correct format, but you also want the monitor to be as close to that as well. So on this diagram, it actually has the instructions that you follow to tune in your monitor to make this look the best. This is the best way that I've found to be able to replicate the color that I see in game in my recordings. Some people have issues with that and they end up tweaking things here and there. I like to go with an industry standard, as to say. And the best way of doing it is going RGB. Even though it says RGB, we will be outputting in studio RGB because of the full. If you change it over to limited, you'll be outputting in just RGB. So make sure it's on full for all of your displays. The output color bit depth, don't worry about that. Just if you can have that at the max that it can go to, it'd be very beneficial. Then hit apply, and basically you now have your graphics outputting in a standard color format. Your screen is now configured to the standard color format, and you're pretty much visually ready to go. Another little tip that I have for you is search for control panel, find the sound thing, and just drop a shortcut on your desktop. This is going to be handy to look into. I've simplified my audio devices for this situation. I've disabled a lot so you can get a rough idea of things. Go straight into communications and turn that to do nothing. If you do not do this and you end up playing a game and you've got other people talking to you voice over IP, it's going to mute your game. But that's one of the worst things that you can have, because we're going to be doing some interesting things with the audio. So you don't want Windows interfering with what you're doing. Also, make sure these are unticked. Show disabled devices, show disconnected. So you're only showing the devices that Windows has got. I have a headphone jack on my microphone, so that's there. This is the monitor I'm currently staring at. This is the one that OBS is currently recording on. This is my motherboard sound card, and this is my PCI Express sound card. This is my raw microphone going in, and this is my lovely microphone that you're currently listening to. This is the capture device for my Elgato. This is a stereo mix for the Realtek. I'll go into that later. And same deal with here, what you hear. So I've tried to simplify it just for these examples. One of the most important things you're going to want to do is, whilst you're here, go here. So right click, go down to properties, go to advanced. Have a look at all the settings on your devices. Like this has a wide range of things I can select. If I go in here, this has also got a wide range. My TV has a wide range of what I can work at, but this has a limit. So I now will treat this as my limit for audio. So 24-bit, 48,000 hertz. This is your sampling rate and bit depth of your audio. The best thing to do is to have all your devices on all the exact same settings. So 24-bit, 48. As you saw, all these are like that. And also in here, it's all also set to the equivalent. The only one that doesn't conform is my digital audio, but it's 16-bit, 48,000 hertz, which is fine. You run into a problem if you have a higher value going into a smaller value, because it's got to resample the audio. And one of the key things you want to do is have as least amount of stress on your PC as possible, because you're going to be riding a knife edge depending on what sort of games that you run. So always try and make sure your audio is set right. As you can see, all my devices are basically set to talk to each other perfectly, and that is something you need to replicate. Don't be surprised if what you have on hand doesn't have 24-bit. Doing your entire system as 16-bit 48,000 Hertz, perfectly fine. You probably won't notice a difference between them, to be honest. And you can do an entire setup like that. But I kind of just like that 24-bit niceness because it's why I've got the components that I have. So we've got a brief rundown of all the devices that we've got in this PC ready to go, which is basically a good thing. Next thing you want to do is go right click on OBS, go properties and go compatibility, tick run this program as administrator and go OK. This will allow the OBS program to work more efficiently, be able to capture more things, and also the hotkeys that you set will also work when you're inside a game, which is incredibly handy. One of the more challenging things to try and express and get across is your system. So I've just brought up Task Manager to give you some idea. So i9 10900K 20 threads, even just in this little situation, it's doing a bit of work. My memory 32 gig, my graphics card, because I'm recording, the video encode is going. And that is where you're going to have some fun at games. Because when you're wanting to do something like play, record, you may think you're only doing two things, but you're actually doing three things. You need to find a balance between Windows, OBS, and the game. Because all three of those will be competing for resources on your system. And I cannot stress that enough. If you're playing old games, it's going to be less of an issue. But if you're playing the latest games, it will become an issue. An example of this is I recently did RoboCop Rogue City as a Let's Play. And that's an Unreal 5.2 game, if I remember correctly. If I had a single monitor and I was just playing the game by itself, I could have all the settings on Epic and I could run it at 1080p with DLS quality and get a solid 60 frames per second. As soon as I activated my second monitor, which is what I put OBS, and I really recommend using a dual monitor setup so you can monitor your OBS whilst you're recording and streaming. What I found is my frame rate went down to 55 frames per second. And that is just having a second screen loaded. And then once I had OBS loaded and doing what it wanted to do, that compounded the issue to the point that I'd get about 52 frames per second. You really want to try and work to try and FPS cap to what you're recording at, because it'll make the software run better, because you're always supplying it frames to be able to deal with. But the other factor of it is if you're not giving a smooth playback in what you're playing, your video is actually going to look worse than what it does on the monitor. Like on the monitor, you might have a VRR setup or G-Sync or FreeSync, which solves some of those issues of those frame dips, but it would be really apparent on your recording. So in that situation, I actually reduced the quality to balanced, and that is something that you're going to have to learn on a game-by-game basis. Running it up, see how it feels, see how your FPS are doing, and you may have to dial back the graphics to get it running. Another thing you may have been noticing is the number of drives that I have, and there is a good reason. There's going to be a lot of people out there who are not going to have a setup quite like mine that I've been building up for quite some time. and you may only have one drive in your PC, and it's got Windows on, and it's got your Windows install, and it's got your OBS. Well, the problem is having all of those three things that you're going to be doing running off of one drive is going to create problems if you need to play a game that has extensive loading sequences or very heavy asset streaming off the hard drive to get the textures on the screen. So what I kind of do is I work on the principle of I have my OS drive, I have my high-speed games drive, because this is an M2 drive, that's just a solid-state drive. That's my games overrun, which is just a normal physical hard drive. And this temp drive is my recording drive. So if you think back to what I said, that you got three things competing, Windows, OBS, and the game, my recording's going to be going onto a third drive completely dedicated to it. My game's going to be loading off of another drive completely dedicated to it. And Windows is going to be running itself, because I'm lucky I've got Windows 11 Pro. So I can actually tell it when to do Windows updates. You're probably not going to be in that sort of position. If you're running a home version of Windows 10 or Windows 11, it's going to download and try and install the updates whenever it can, as soon as it can. And this can lead into problems where you're playing a game and it feels really choppy, and it's because Windows is trying to install an update whilst you're running the game off the same drive and also recording to it. And that's all stuff that gets really, really difficult to problem solve. The number of actions that in that situation it's trying to get the drive to do, it will not be able to do all of them properly. So your game will suffer, your drop frames on your recording because it can't write to the disk at the same time. I know that it's not going to be reasonable to everyone to be able to set up their system like this, having multiple drives for different things and different types of games. But if you are in that situation where you've only got one drive in your PC, get an external drive. Not for Windows, not for games, for your recordings. Most USB 3 hard drives will be quick enough for you to be able to dump your recording onto the external drive, and it takes that little bit of pressure off your system. I really recommend, if you really want to take this on as a serious hobby, that you do increase your drives so you have an OS drive, a games drive, and a recording drive, because it's going to save you so many headaches in the long run. So, you've downloaded all of these, and you're like, what do I do next? Well, next we need to load up Audacity. So there's a couple of things we need to do in here. So we're going to edit preferences. So in the preferences, you set these to the same as you set the audio, and you also set the default bit depth to what you set in the sound cards. The next thing you want to do is go over tracks, make sure it's on waveform and logarithmic dB. This probably makes no sense right now, but it's going to be very helpful for you in the future. Next thing you want to do is you'll have lame MP3 import, but this will be blank. So you need to go to the download, and it says installing FFmpeg, and it takes you to this site, and then it's download from here, and then it's got a link for Audacity 3.5. You download it, install it, and you go okay there, you close it, and then when you reopen Audacity and you go preferences, it will now list that. What this lets you do is it allows you to import your raw recordings that you've been making to be able to have a look at the audio tracks, and in a little bit I'll actually explain why that's a bit of a benefit. So that's the nuts and bolts of things. So I've probably been rambling for far too long, and you're probably going, where's the OBS side of this? I already have OBS running because I'm recording, so we'll just go launch anyway. This is probably very daunting right now, but what we want to do is, if you have a box come up, cancel it and just go Profile, New, and you call it Bass. And you go Scene Selection, New, Bass. Because this is going to be your base template. If you ever need to make a new OBS profile for something specific, this is going to have all your things already set up. So let's go through some of the simple settings. In advanced, that is standard. Color format is correct. Color space, we want to match that to what we put in our monitor settings in control panel for your graphics card. So RGB, and it's full. So click apply. Then you go video, and you see it's detected the maximum that my graphics card is connected to. At the moment, it would have capture at that size, which is 1080p, but it'll output at 720p. This is like rescaling. You don't want that. You want both these numbers to be the same. For you, it could be also 1440p or 4K, depending on what you're doing. Here, select 60 frames per second, click apply. So now you're capturing and outputting the same resolution. There's no changing going on there. Audio, as you see, sample rate 48,000, and channel stereo. You can do more than just stereo. If you're using headphones, you'll get virtual 7.1 depending on your setup. YouTube does accept like up to 5.1, but it'll only store it on the servers as virtual 5.1 stereo. Twitch, however, does actually support 5.1 transmission, and it will actually keep it in 5.1. If you do that, I recommend you do not have a microphone, because doing the things with the mic in that situation is a bit of a headache. I've tried it, trust me. Next thing you want to do is go to output. This is where we're going to get into the nitty-gritty. So we go over to advanced. We're not going to be focusing on streaming, that's another video. So first thing you want to do is go and set all your audio tracks to the maximum. Like I say, this is going to be our base template for any other project that you make, so it's best to have all the audio set up all ready to go. Our recording, like at the moment, it's wanting to record on my OS drive, and I already said that's a no-no. So I go into my temp drive, into recording, select that as my folder. Audio tracks at the moment only have one ticked. In a future video I will be explaining how you can build redundancy into your recordings for when things go wrong, but I'm just trying to get you up and running at this point. Which brings us to the most pain in the rear end of all this. Your encoder. Your video encoder is going to be the bulk of what needs to be looked at in regards to recording. This dictates the quality of the videos that you're going to be producing. If we have a look in here, and this will change based on AMD and Intel cards, you will see that we will have a range of options. You'll have some that say 264 or 264/AVC. Or you'll also have one called HEVC or H265, and you'll end up with a couple of AV1 variants. This is basically the thing that's going to actually make your video for you. The best way to think about it is it'll grab a frame that's on the screen, and then it's going to convert that into an image, record it, then put that sequentially into a video file, and as each frame goes it builds up and you end up with your video. 264 stroke AVC is the oldest available in regards to video encoder. This comes in two flavors normally. This will normally come in an X264, which completely runs on your CPU, and H264 is hardware accelerated by your graphics card. H264 has been widely available on GPUs for quite some time, so unless you're using a graphics card that is over 10 years old, you should find a 264 option in there. This standard has been around for around 20 to 25 years, somewhere in that region. This is the type of codec that was used in regards to DVDs, and it's the best way to think about when this codec was actually manufactured. Because of how videos have increased in size, and this is the oldest of the three types of encoders that we're looking at, the encoder was designed for a specific standard in regards to resolution. Over the years, 264 hasn't aged that well, because as you go through 720p up to 1080p, then up to 1440p and 4K, because of the age of this encoder and the way that it does the actual work, it gets less efficient, so your file sizes for recording will grow in size substantially as you go up through the resolutions. The HEVC or 265 option is what was designed to actually replace it. You will now commonly find on ultra high definition Blu-rays, for example. This has been more catered for the HD resolution all the way up to 4K and even beyond. This encoder is so much more efficient in regards to storing data that you can generally run at half the bit rate of the encoder that you'd use for 264, which is a great thing for saving space when you're doing the recordings. To give you some idea of what I mean by the way that they work, I found this site, and it'll go through the difference between H264 and H265 if you want to understand what's going on at a more fundamental level. But the thing that I want to bring your attention to is this example here and here. H264, X264 breaks the image down into grids, so every single square is accounted for. H265 will actually vary the size of the grid, so it'll make it more efficient on things that are not moving as much, whilst it'll increase the detail in regards to objects that are moving, because as you see, the size of the squares can actually be adjusted, and this is why H265 can be more efficient. It further goes on to actually explain the average bandwidth required per resolution. So if you're running at SD, 264 will need 1.5 megabits per second, and 265 needs only half of that at 720p. again, only needs half of it. At 1080p, again, half of it. And this is where it gets interesting, because at 4K, 32, 15. And this is what I mean by it gets more efficient the further up the resolution that you go. So this option is going to be dependent on your graphics card situation and your CPU situation. Like I say, if you have a very old graphics card, it's probably going to be wiser to use the 264 to take the workload off the graphics card, so you can have the graphics card focusing on the actual recording. There is something else you need to take into account when running the hardware accelerated versions of recording codecs, is these will also put extra strain on your GPU. So something that you'll have to get into the habit of is tweaking your actual setup. What I mean by this is there's going to be times where you will have to lower the settings of the game to be able to get a smooth 60 frames per second. It is very important that you try and aim for a locked 60 frames per second when playing the games. With monitors that have VRR, FreeSync or G-Sync, it takes the visual problems that you'll have in regards to what you see on the screen. But if you're actually playing at less than 60 frames per second, the monitor will be able to compensate for it. But your actual video will end up looking slightly different. It'll end up looking slightly choppy because it's not getting the constant 60 frames per second. So that needs to be one of your tenets going forward, is actually going into the game settings and adjusting them, even if it means that before you actually do your game recording for, say, your channel or whatever you're doing this for, is that you run it up and do a test situation with the game running, so you can actually see if you need to lower the settings a bit and try and aim for that 60 frames per second. One of the tools that I use in this situation is an application called FPS Monitor. It allows me to have real-time information in regards to what my CPU is doing, what my GPU is doing, temperatures, RAM, gives me a nice little FPS counter and frame time. And at this side here I have information about what my video encoder is doing. So even though I'm in this situation where I'm just recording my desktop and doing all this, as you can see, it is keeping my encoder at about halfway in regards to use. This UI, I use this because it's not embedded into the video game. So I can actually run a game and record it, and it'll look like I'm just running the game in the recording, but I actually have this overlay over the top of the game, so I'm always aware of my FPS and how my system is performing. This might be something for you to look into if there's much call in regards to how to actually use this program and set it up. Put a comment in the video or join my Discord and ask me questions. More than happy to answer. But that is also another key important fact. Try and keep an eye what's going on with your machine. So going back to the old encoder situation, let's say in my situation, which is what my normal situation is I normally record in 265 because it's so much more efficient. If we just look at that image again, you can see how and why it saves space. The most awkward bit to get to grips with is the rate control. On NVIDIA cards, you've got 4 different options. Lossless, I always avoid because you end up with absolutely silly sized video files. I also avoid using CQP. This is where you actually decide a minimum quality that you'll accept in regards to the image. The problem with using that type of system for recording is it means you won't have any idea how large your video file is. An example is when I've done point and click adventures on my channel, using CQP, it does kind of make sense because I end up with really small video files because it's looking at what's on the screen, maintaining a quality, and then outputting to that quality. But if you run a game like Crysis 3, when I did on my channel, using CQP was a bad idea for the simple reason a 2-hour recording of Crysis 3 would end up being in the range of 200 gigabytes for 2 hours. And that is just a really difficult video file to put into video editing software. So for this reason, the things that I'd recommend is either CBR, which is a constant bitrate, or VBR, variable bitrate. So we're looking at the CBR and it's instantly defaults to 2500 kbps. This is how much data it is allowed to use on your hard drive every single second. This does not include your audio data. So if we look at 2500 divided by 60, that means every single image has to be 41.6 recurring kbps. And that is not a good file size for having an image in, let alone it being a 1080p image. So how I decide my bitrate in regards to what I'm going to record at. So I go into my search engine and I go YouTube upload bitrate. Go there and it basically gives you what they recommend in regards to your video format when you're uploading videos to YouTube. I go to the bitrate. Even though I said this video is not covering HDR, I ignore the SDR upload specification. I use the HDR option because it gives you more room for error in regards to your video production. So if we look here at our resolutions, so 4K, 2K, 1080p, 720p, it's got for 48, 50 and 60 frames per second, and we're working at 60, it's giving us these details in Mbps. So for 1080p, it recommends an upload of 15 Mbps. But that's what you're going to upload to YouTube. There's a high chance if you're watching this, you're going to actually be doing recordings that you then edit and then upload. So for that reason, what I normally do is I take this value and I double it for the resolution that I'm at. So I've been talking about 1080p, so it says 15. So we go over to OBS and we delete that. We put the 30 and add a 0. This way it's now at 30 Mbps. And that is the bit rate that is constant. It'll try and keep to that rate of data being recorded onto your hard drive. The problem with it is games are getting more graphical in nature, and this can lead to problems where if you've got an extremely complicated scene on the screen, you can run into a problem that the quality will just dip down a bit because it's running out of bitrate. This is why I use VBR. And VBR, it tries to do the same, which is maintain that 30,000 kbps, but you can also set another option called max bitrate, which I set to 50% larger than my actual recording rate. This way, if you get to a scene in a game and it gets very busy, then it will actually have room to be able to exceed the bitrate for that short period of time. And in case you're wondering, if we go back to our little calculator and we go 30,000 divided by 60 frames per second, you see how we're now at a nice big number. And this will be the amount of data that the OBS can go up to in regards to maintaining quality of each individual frame. So if you're working in 264, what I'd recommend you do is again look at this table, 15 megabits, and instead of multiplying it by 2, I multiply it by 3. So in CBR format, I would record at 45,000 kbps. With VBR, I would alter that to 60. Because it's an older encoder, you need to give it more bitrate to be able to maintain the quality. But back to the way that I actually do things, which is HVEC, and then we change that and we go 30. There's our 45. Keyframe interval, I recommend for recordings keep that at 0 auto. A keyframe is basically if the video editor detects a change in scene, it will actually do a complete new frame and use that as the reference point for any data that's moving. The preset, you will need to again run up a type of game that you're intending to play and play with this setting to see how it affects your performance of the game. And you've got two ways of balancing it out. If you find you're hitting the 60 FPS cap and your GPU's not going nuts or so forth, increase up to slower. If you actually try and go 7, you won't notice a difference between 6 and 7. So you may as well just leave it on 6. But if you find that you're recording and playing the game and OBS is flagging errors saying encoder overload, stop the recording and basically lower this setting. This is basically the setting that defines the quality of every single image. With an RTX 3080 like mine, it's generally P6. For multipass mode, because I want it to go onto the hard drive as quick as possible, I go single pass and look ahead. So that is how I record. If we have another look at this, the AV1 is the most recent codec, and the reason I'm not really talking about it is it does put a bit of a load on your processor, because in my situation I can't hardware accelerate it. So if you've got an Intel card that's current series, a Nvidia card that's 4000 series plus, or AMD card that's 7000 series plus, you will have access to a hardware encoder for AV1. This again is more efficient than 265, but because it's such a new encoder, not all video editing software supports it, and this is kind of why I'd recommend at this point of time of recording that you do not go for an AV1 option in regards to recording, because now we've got to have some fun. So we go add source, and as you see, there's quite a few things. The first thing that I always do, and we call this HD, is I go into this drive in here, pictures, and find my HD test pattern. Interesting thing, now it's got a red border around it. You can resize it, you can move it about. If you go right click, you can go transform, and you tell it to fit the screen. If I could just click the button. I always leave that as the bottom layer of my recording setup. This way, if there's any problems in the recording, I've literally got access to any color information that went wrong in the video file because I have this reference. The next thing that you'd want to do is set up your sound card. So we call this sound card. When it comes to using device timestamps, turn it off. If you use it, what will happen is your audio and your video will slowly go out of synchronization the longer that you record for, and resyncing audio with video is a nightmare. So I've told it that I'm using my creative sound card, so I go OK, and over here I right click and I prefer vertical layout so I can see what's going on. So that's our sound card pretty much in, ready to go. Next thing is you want an audio input capture, and we're going to call this mic because it's your microphone. So I need to grab my source, which is this mic in wave 3, and as I talk you can kind of see where it's coming out, and you can see when I'm quiet it keeps bouncing at the bottom, and that's because it's picking up other sounds around me. So how do we fix this? You left click the mic and you go right click and go filters. Now we go into this plus button and add a VST plugin. First one we set up is called noise. And in here we go for the REAFIR standalone. We open this plugin and this is what we're greeted with. Basically it's showing a waveform representation of all the frequencies that compose my voice. But if I'm silent, you see all that noise in the background. This is what we're going to do. I'm going to subtract it. So we change it over to subtract, and when you're ready, you tick this box and you don't talk for 5 seconds. So now what's going to happen is basically it's going to take out any sounds that are inside that level. So if I stop talking again, we can tell that it's working, because if I move it over here, whereas before we'd get a bit of noise down here, watch what happens when I stop talking now. Even though it was picking up noise, it's cancelled it out. So that noise is like PC fans, electrical hum, any fan, desktop fans you have going, just general noise frequencies. The next one you want to do is add another VST plugin and call it Gates. We're going to set up a noise gate. This is done by selecting REA Gate Standalone. So we open this plugin and you're greeted with this box. Yep, it's very daunting, but here's the thing. What you want to do is keep an eye on this bar. And then what you do is watch for where it drops off and kind of work out where your voice is. Like right now, the way that I'm speaking, I think I could stop any noise up to here, because that's what we're doing. We're basically telling it, don't put any sound until you hear over this type of volume. So this currently says infinite. So if we bring this up to what, about 40, so we're around here, maybe take it one step, 30 minus 39.1, which means our gate is operating here. So with a little test we do. So right, the little test I'm doing is if I bring this all the way down and I'm going to click my mouse. See that? How it is jumping up and down in that region. So if I keep with that 39 minus, and that's me clicking again. And that's kind of how you can get rid of some of the sounds, like your controller sounds. Just be sure you don't cut it too close to your voice, otherwise you'll cut off the beginning of your words. The next one you'll want to do is another VST plugin, and we call it EQ. And we use the REA EQ standalone. This is very complicated because you can actually change the shape of your voice in this setting. The reason I'm putting it here is depending on how you respond to the videos that I'm doing, I may come back and revisit this entire situation, because EQ can be a very powerful thing, but it isn't a one setting fix all situation. You've got to go with what works for you, and it's very complicated to work out. However, there is one thing that you can do that will improve things. These numbers here relate to the red dots, which are different frequencies that the human ear can pick on. So what we want to do is on the first one, we change it to 70. So it's down there, and then you want to do a high pass. And what that's going to do is it's just going to ease out all the really low tones, which will definitely benefit if you have low rumblings that's going on in your environment. So with that done, we can lead on to the next plugin, if I can spell, which is a compressor. This is REA Comp. What this is going to do is it's going to enable us to like smooth out our voice, make our loud more quiet and our quiet more loud. And the way that I always do this is I turn on classic attack, and then what I do is just using the wheel mouse, bring this down, and I try and just put it up where my voice is actually naturally talking. So now what's going to happen is the idea is if anything goes over 20, it's going to get compressed. But at the moment we have a ratio of 1:1. So I normally do a ratio of 4:1. So once I hit that 20 dB, it'll take 4 dB over it to go up by 1 dB. which is why if you look at this red thing and I do hard sounds, that's popping up to top. Stop me from like busting the mic. So that's kind of all good, and we're looking at where we're actually kind of talking, and you see how our voice is naturally just dropping into like this kind of area. If you find yourself in the situation that you're doing this compression and it's not getting into the zone that you want, you can apply wet to just give it that extra little boost to jump it up. Like in my situation with this mic, I think an extra 2 dB would just get me to sit constantly in that zone. I'm not going into the red much, so it's going to do it pretty nicely and it'd be nice and audible. So the last thing you need to do is a limiter. This is to stop us from popping the mic. So the microphone will sort of peter off anything that hits -8, which is obviously in that red. So with that in mind, what I'm going to do is I am going to open these filters and we drop you over here like so. So I'm going to turn these off and I'm going to hit record, and then I'm going to speak into the mic, and then I'm going to activate each one until we get to the end of the chain. So this is me testing the mic with absolutely no effects. Then I've just activated the noise, so we're getting rid of some of the background hum. I've now activated the gate, so now you shouldn't be able to hear me clicking my mouse. Then I turn on the EQ just to smooth off the bottom end. I now activate the compressor to get my volume in the range I want. And now I've activated the limiter so we can actually not bust and go into the red zone. And then I go stop. And I go in here, load you, go file, open, 40 seconds. So audio setup playback device is this. So let's have a listen. This is me testing the mic with absolutely no effects. Then I've just activated the noise, so we're getting rid of some of the background hum. I've now activated the gate, so now you shouldn't be able to hear me clicking my mouse. Then I turn on the EQ just to smooth off the bottom end. I now activate the compressor to get my volume in the range I want. And now I've activated the limiter so we can actually not bust and go into the red zone. So as you can see, it gets more uniform as we go on. If we kind of zoom out, that's kind of what you want to see. Nice smooth sections for your talking. But that's us having got the microphone sorted. We now need to actually do something in regards to getting our sound sorted. So I go into here. Nope, not there. Into here for vids. Live. It's always the last place. Right. So if you look at this, what you can immediately see straight away is the game audio is peaking. So what I'd recommend is sort of bring that down till you get it in the area that you want. Like in my instance, I want it minus 10 dB. But if you notice, what's happening now is my speech is probably getting cancelled out by the noise. So with that in mind, what we want to do is go to the sound card, go filters, we add the OBS compressor. Because what we want to do is do something so when audio is detected on the microphone, it reduces the sound card volume so you can remain audible. So we tell it to look at the microphone. The ratio is at 10:1, so once it's got to go 10 times over the dB for it to increase by 1. So with that in mind, we need to set an activation threshold. At the moment it's at minus 18, which would put it around here. But because the ratio in compression is a multiplier in a way, you want it to activate a lot earlier. So in this case, I would suggest that we activate it at about minus 40. Then we go back over to our music, we click play, we wait to see where it comes out, and then we start talking. So now if I start talking, you see how the audio that you're listening to is dropping down. But what you're also noticing is it's very quickly restored. So what you need to do is increase the release. I generally recommend between 250 milliseconds to 500. 500 is basically half a second. So let's go for that. There we go, 501, close enough. So now when I'm speaking, it is actually dropping down quite well, but you actually see the game's fairly low. So what we want to do is just bring this probably up to about 34. And there you go. You see how it's dynamically reacting on here in regards to the audio. When you're not talking, the game is coming up, and when you're talking, the game is going down, which is ideal for the situation that you want. So with all that said, we've got our bass template. We've got our microphone and we've got our sound card set up that you're plugged into. You've got your microphone all filtered, it's working fine. So now we've got this bass, we go duplicate and we make one called recording PC. And then we duplicate this and we call this recording PC. Because this is going to be our setup for recording a PC game. So the next thing you want to do is you want to add your possible capture devices. The first one is a window capture. So let's say that. You've got the option to capture the cursor. In this kind of situation, I recommend that you do. And you get basically this. Again, if you left click, you hold, you can move it about, you can pin it in a corner, you can even full screen it and play with as you need. This is very handy if the game that you're running only runs in window mode. So it allows you to actually just capture the window without actually capturing your desktop. So that's one option for the way that you capture. The next one is display capture. And we will set it to that and give ourselves an infinite screen, which is absolutely nightmare. But this allows you to capture an entire desktop, everything that's going on. This I use only in backup situations when my preferred method of capture doesn't work. So I always consider, I very rarely use window capture. I sometimes have to use display capture because a game won't work in my preferred format. So let's turn off that and go to my preferred, which is game capture. Game capture, as it says, capture any full screen application. Basically, all these you ain't got to worry about. Color space, sRGB, as we discussed. Hook rate, fastest. This is how quickly the OBS will grab the image from the game, and considering you want as lower latency in everything that you do, going for the fastest hook rate makes sense. But as you see, we've got a red dot up here, so you need to correct that by going transform fit fill screen. Now when you run a game in full screen or borderless full screen, it will appear. So this is kind of the way that I do my recordings visually. So when I start recording, my recording will always have this image at the beginning, which is my color reference chart for editing the videos. Then I launch the game and OBS catches the game and it goes over the top of this picture. And that's how I record. There can be a situation where you may want to capture, say, a webcam. So, and also have that displayed on top of everything else. So if in this instance I did this and grab you, make you full screen. So there we go. My Audacity clip. So you want to now capture your webcam. Go video capture device, add webcam. And there's that. So this is directly capturing from my webcam. And we go custom, because I know it's in that format. Then we set it to match the frame rate, which is 60. We tell it the color space, and we'll leave it as default color range. And then you can move your webcam, resize it, put it in the corner, and that will now appear in your recording. It's something that you may want to do. It's not something that I do myself. I more use the webcam if I'm going to in streaming. But you can set it up, and just by clicking that, you can toggle it on or off depending on your need. So that's how we kind of do PC recording, which is very, very interesting. The next thing that you'd want to do is look at setting up hotkeys. In this situation, a brilliant tip that I started with was when I was first starting, I'd use the square bracket on the keyboard next to P to start and stop recording. And I'd use the other bracket to stop streaming. But that isn't going to be necessary in this video, but it's something to bear in mind. So this means a single press of a button, you'll start your recording. Again, this is where having two monitors will be handy. If you're running on one monitor, you're just going to have to hope and pray that OBS keeps its crap together whilst you're playing the game, because you can't observe what's going on with OBS. Go into your hotkeys, scroll down until you see mic. And here you can set a mute, unmute button. This is just like this option here, start, stop recording. So in the example that I gave is I use this square bracket and then the other square bracket. So if we go down to the mic and we say set it to hash, because I don't think I use that key a lot, and go apply. Now when you press hash, you can actually mute the microphone, and this may be handy for if you need to step away from the keyboard, or you have a mobile phone that goes off. This will allow you to be able to actually mute your mic, keep the game running, or if you feel like you're going to sneeze, you could just hit this button, sneeze, hit the button again, and away you go, carry on talking. So now you're at the point where you want to record from your console. So what we do, go to base, profile, duplicate, and we call this recording console. And we duplicate this base and call it recording console. And then we are on both of those. So we've got our HD image, our sound card, our microphone all set up, ready to go. So the next thing you want to do is add your video capture device, and then I change it over to my capture card. I tell it that it's custom and it's 1080p. Match the output, video format any, color space 709, and this is where you need to pay attention to your console, because if we go screen and we go video output settings, at the moment I've got the RGB range on full. You need to match that setting with what's on your console. The other thing you want to do is we got an extra audio device because we've added this, which is going to mess up everything. So we just mute that. We're not going to worry about that at all. If you're using a PlayStation 4, and this kind of is pretty important, go into your audio output. It will normally be on HDMI out. If it does this, it means it's outputting in 5.1 audio, but most capture devices are only stereo capable. So if you're playing a game that has a lot of voicing, the voicing is normally done on the center channel, which you won't have access to because you can only record in stereo. To solve this problem, you just change it to optical out, don't tick anything, and go OK. And now the PlayStation 4 is set for stereo output over HDMI. So with that in mind, the next thing we've got to do is test the game audio and get that sorted. While that's loading, as you've changed the settings on the video capture device, we're no longer capturing in sRGB because we changed it to Rec 0709 because of, in here, it says REC 709. So make sure you change those settings over. Right, so we've got our console running, we're getting the video, and we're all ready to record. But as you see here, there's audio coming, but we actually cannot hear anything. And there's a very, very simple trick to solve this problem. We go into sound and we're going to loop our audio from the capture card into our headphones. This is really, really easy, and a lot of the stuff that I'm going to do later is going to rely on this idea. Because if you're going to listen, it allows you to take a recording device and output it on a playback device. So if we tell it to listen to this device, it now means it's in a mode where whatever is being played on the recording device can be output to a speaker setup. So these are my headphones. I go OK. And as we can see, the audio's there, but the audio isn't as high as where it should be. So in this situation, completely remove the offset of the volume, and there you are. And now you have a setup that is purely designed for capturing your console. Like I say, this is going to be the first of a series of videos that I do. The next one will be building on these foundations, and it will be concerning setting up streaming. So hopefully I should be able to have that one done within a couple of days of this one going up. And if you have any questions or you need some opinions about the way you have it set up, please comment below. I'd like to hear from you.